Mark your own. Here we go. Oh, I haven't written this for a while. Who's my favorite student? Good old Ann Serkey. What's the radius? To be honest, the very first thing I did here, Nick, it's a trick I do. I don't want to make sloppy mistakes. So if I'm reading a question, anytime I see units I don't like, I actually crossed out the 2 minutes and I wrote 120 seconds just so I didn't accidentally do a silly substitution. Anyways, they gave me speed. They want the radius. I think I'm going to use that centripetal speed is 2 pi r over the period. To get the r by itself, it's going to be v times t over 2 pi. It's going to be 170 times 120 over 2 pi. I said, okay. 170 times 120 divided by bracket 2 pi. Do you get 3,250? And at first I was a bit worried because I said, wow, that's over 3 kilometers. But then I said, no, you know what? That's probably about right for an airplane banking around a corner. It probably does trace out a circle with a radius of a few kilometers. This is an airplane, not a little car going around a corner. So I'm okay with that. So I said 3,250 meters. If you got that right, 2 out of 2. Otherwise, I would probably go something like this. Half mark for that. I'd probably go 1 mark for that and a half mark for the answer, or something like that. B, now they want the centripetal acceleration. I have 2 options, Justin. I can use v squared over r, or I can use 4 pi squared r over t squared. There's no advantage between one or the other. In both of them, I'm going to have to use an answer from part A no matter what. So I went with the least amount of typing. I used v squared over r. I said it's going to be 170 squared over, I wrote 3,250, but of course I used my answer button. You get 8.9 meters per second squared? And I was okay with that answer as well. I said, I think these numbers look like a passenger jet. And when a passenger jet banks, they don't want the customers to feel a big difference. What's your normal acceleration? What's your normal? What are you all feeling right now? 1g, which is 9.8. These passengers are pulling a little bit less than a g. If you were on this airplane, you might notice that you were feeling a tiny bit lighter, but it wouldn't be like you'd be feeling uncomfortable. You'd probably look out the window and say, oh yeah, we're turning, that's what's going on here, cool. And you'd enjoy the view rather than be feeling the physiological sensations of, I feel way lighter than normal, or I feel way heavier than normal. So I'm okay with these numbers. I probably would go half mark, 1 mark, half mark, or something like that. Number 2. Ooh, they gave me hertz. They want the centripetal force. I said, well, it's going to be MAC, which A? Well, the fact that they gave me hertz means they gave me the period. The period is 1 over the frequency in hertz. It's 1 over 5, which I'm pretty sure, correct me if I'm wrong, the period's 0.2, I think. So I said, okay, I'm going to use the M 4 pi squared R over T squared. I said F equals 12 4 pi squared 6 over 0.2 squared. Okay. 12 times 4 times pi squared times 6 over 0.2 squared. Do you get 71,100 if I go to 3 sig figs? And I started to freak out a little bit, Hannah, because that's a really big force in newtons. And then I went, wait. I looked at the numbers. Hannah, what's the mass in this question? That's about 25 pounds. In fact, that's really similar to that lead fishing weight that I have on the desk in front of you that I bring out once in a while. It's a big mass. What's the radius of this question, Hannah? 6 meters is about from me to Grace, roughly. How fast are we spinning this? 5 times a second. That's a huge force. This is almost like a lawnmower from hell kind of a situation. This is a massive weight spinning really quick. Yeah, it should be a big force because a human being could not do this. This is some kind of machinery. So at first I was nervous, Trevor, and then I kind of zoomed away and looked at the numbers and said, oh no, that makes sense to me. It's huge. Number 3, they want me to find this. In terms of part marks, I would probably give you 0.5 for finding the period, and then I would probably give you 0.5, 0.5, 0.5, or something like that. But if you got the right answer, it's 3 marks, Mr. Dueck. If you got the right answer, I got an extra mark to give away then. So how about Mr. Dueck? That's 1 mark, that's 1 mark, and that's 1 mark. There's 3 marks. If you got the right answer, 3 out of 3. Here, they want AC. I'm going to use V squared over R because they gave me a speed. This is really just plug and chug. It's going to be 5 squared over 0.25, and you get, is it 100 even? Should be 100 even, yeah? Meters per second squared. About 10 Gs if this was people. Not a good situation for people. Number 4, a Ferris wheel, Mr. Dueck, a Ferris wheel. We're on the top. So at the top of the Ferris wheel, this is a job for a free body diagram. I have gravity down, normal force up, because that's which way my head is pointing. Why did I draw the normal force smaller than mg? What path are we tracing out? A circle. Which way is the winning force pointing toward the center? Yeah, absolutely. So my equation, you're right, Gabe, is going to be winner minus the loser equals m4, let's try that again, m4 pi squared r over t squared. I noticed they gave me the period. They want the normal force. You know what? It's going to be the swappy dance. I get mg minus m4 pi squared r over t squared. That equals the normal force. Do the m's cancel here? No, because normal force is dependent on your mass. This is why heavier people actually experience amusement park rides to a greater degree than lighter people. It's going to be 65 times 9.8 minus 65 times 4 pi squared 9 all over 25 squared. 65 times 9.8 minus 65 times 4 times pi squared times 9 all over 25 squared. You get almost bang on 600? So 600 newtons. If you got that right, 3 out of 3. Otherwise, I would probably go 1 mark for that, 1 mark for that, half mark for the numbers, and a half mark for the answer. What about at the bottom? Well, at the bottom, I have gravity down. Why did I draw normal force so much bigger? What path are we tracing out? A circle. Where is the winning force pointing? Towards the center. So at the bottom, I have normal force minus mg equals m4 pi squared r over t squared. I plussed the mg over, so I ended up with mg plus m4 pi squared r over t squared. I carefully plugged in the numbers. By the way, I noticed, Ben, that my expression for part A and my expression for part B were almost identical, except in part A there was a minus sign, in part B there was a plus sign. I have a natural lazy streak, Ben. I said, you know what? I'm just going to backspace and edit on my calculator, and I'm done. Did I go on a rant about calculators in Physics 11 occasionally? I did. It's actually for this trick, but in the next unit, we're going to use this backspace, change one number, and edit quite a lot to avoid having to type something hideous. Is the answer 674 newtons? If you got that, 3 out of 3. Otherwise, I'd probably go 1 mark, 1 mark, 1 mark, or something like that. Then I'd turn the page. Oh, Rollercoaster! Cool. This question wants me to find how fast. I'm probably thinking v squared over r, just a guess. This is a job for a free body diagram. What are the forces acting on this person? Get the obvious one, mg. What else? Here, for a roller coaster, when you're at the top, normal force is down. In fact, when I say, who's winning, the answer is, everyone's a winner. It's like kindergarten. Normal force plus mg equals mv squared over r. I don't know the normal force. Or do I? Experiences a normal force of 4.5 times their weight. When I say weight, when I say weight, what do I mean by weight? mg. So you're telling me that actually the normal force is 4.5 mg's plus mg equals mv squared over r? Hey, Nick, can little kids and grown-ups go on this ride? Why? Really? Well, that's convenient. And not only that, I have like terms. This is 4.5 G's plus 1 G. Yeah, I think you're right. I think it is 5.5 G's. Equals V squared over R. And now I can get they want me to find V? Yeah, the V by itself. It's going to be times by r. I notice I am going to get a square root of GR and other stuff, but as soon as I saw that, I smiled and said, oh, hello, familiar friend. I'll bet you I'm on the right track. 5.5 GR. So I said, okay, forgot the decimal. 5.5 times 9.8 times, what was the radius of this? 11? Square root of that, you get 24.3. Nodding, yes. Meters per second. For 4 marks, I would probably go 1 mark for that, 1 mark for that, 1 mark for that, half mark for that, half mark for the answer. Probably something like that. B. We're again at the top of the second loop, so I think it's going to be a really similar free body diagram. I think, again, we're going to have gravity down, normal force down. I think we're going to have normal force plus mg equals mv squared over r. It says the normal force is twice their weight. Two mg plus mg. Oh, wait a minute. Nick, can grown-ups and little kids go on this ride? Really? Why? So 2g plus g. What used to be considered fast Wi-Fi? 3G? I know it's not Wi-Fi. That's a different band. I should have said what used to be considered fast cell phone data? 3G? Equals v squared over r. So now they want me to find the radius. How would I get the r by itself? Yeah, if you haven't spotted this pattern already, anytime you have one fraction equals one fraction, And you can always make anything a fraction by putting it over 1. Stuff moves diagonally. That's cross-multiplying, but with a vengeance. So I'm going to get r equals v squared over 3g. How fast are we going? 16, don't forget the squared. And g is 9.8. What's the radius of this? 16 squared divided by 3 times 9.8. You get 8.71? If you got that right, 4 out of 4. Otherwise, 1 mark, 1 mark. I'd probably give you 1 mark if I saw that. And 1 mark for the answer. Something like that. If you can give yourself a lovely score out of, holy smokes, 23, that would be delightful. Cool applications. And this first one, I'm not going to say, I like this question, I like this question, I like this question. What I am actually going to say is, I just love this question. I like it when something starts out really ugly and suddenly you get such a clean answer. And this question has some nice depth to it. And the question that I asked you earlier about roller coasters and loops, this is going to explain why the answer is what the answer is. It says this: a roller coaster barely makes it around a vertical loop of radius 4 meters. A, find the minimum height that the roller coaster needs to start from at the top of the hill. Let's assume we're starting from rest, so it's the absolute minimum height. Gabe, what's A asking me to find? I think that's going to be that. Gabe, is there a change in height? Is there a change in speed? Yeah. Is there a yucky, curvy path? You know what this is a job for? How would I solve that? Who remembers? Conservation of energy. Okay, so my first approach is going to be, I'm going to use conservation of energy, but Gabe, I'm going to let initial be here, and I'm going to let final not be on the ground. Final is going to be at the top of the loop, because it's asking, how high do I need to start to barely make it through the loop? And I think the issue is going to be right there. Because if I'm going too slow, what's going to happen? I'm going to fall, right? Okay. Well, conservation of energy said KE initial plus PE initial equals KE final plus PE final. Are any of these 0? Yeah, and that's it. Prince Edward Island is a province. Right? Initial height is not 0. And we're not ending up on the ground. Oh, and I know I'm not coming to a stop up there, because if I come to a stop right there, I'm crashing down. Bad things. So I know that's not the case. All right, well, I may as well expand this. So potential energy, well, that was mgh initial. Kinetic energy was a half mv final squared. And potential energy was mgh final. Hey, Nick, can little kids and grown-ups go on this ride? Cool. Why? Cool. I'd like to look at this, v. That's the speed right there. Right there, what path are we tracing out? A circle, you say. In our circle equations, is there also a v squared that shows up? You know what? Now, here, this is a job for a free body diagram. Let's see if we can figure out what v is, and we're going to do this purely algebraically. So, what are the forces acting at the top right there? Get the obvious one. Gravity. What else? Normal force pointing up or pointing down? Okay. So do a little line like that, and you can make a little note at the top of the roller coaster. we would say this. Normal force plus mg equals mv squared over r. And I went with the v squared because there's a v squared in the other portion. What word did I underline? No, in the instructions. Sorry, not here. What word did I underline in my question? Barely. If you barely make it through, what that really means is, what do you think your normal force is exactly if we barely make it through? 0, because if we go any slower, we won't make it through. If we go faster, you'll feel like you're getting pushed in. You'll have a normal force. So barely making it through, we're going to go like this. Let's change colors, Mr. Dueck. Because we barely made it through. Oh, then what we'll do is we'll just make sure the hill is higher than that so we have a safety margin. And so what I end up with is mg equals mv squared over r. Nick? And I'm going to get the v by itself. Wait. Actually, instead of getting the v by itself, why don't I get the v squared by itself? Because that's actually what's in this equation. I get, yeah, we've seen this bad boy before. And I'm going to replace the vf squared, because that f is at the top, with GR. And I get this. G H initial equals 0.5 GR plus G pause. Don't write H final. What do I call that distance there? Sorry, I didn't hear. What letter do I use for that? Okay, so you ready, Jacob? How far from here to here? How far from here to here? What did you just say? What letter do I use for that? So you ready, Jacob? How far from here to here? R. Yes? Okay, you ready, Jacob? How far from here to here? How far from here to here? How far from here to here? How far from there to there? What's another way to write the height? See the argument? Instead of H, I'm going to put, you can make a little note if you want to in our diagram. That's twice the radius. Now, some weird stuff happens. First of all, oh, what just vanished? Jeez! I mean, yeah. Gravity vanishes. Now, we have seen this happen, I think, once before this year. What this means is, if you transported this roller coaster to the moon, you wouldn't have to change the hill height. Or if you transported it to Mars, it would still safely make it through the loop. In fact, if you transported it anywhere in the universe where there was a solid surface to put the roller coaster on, the coaster would make it through. So I get this. H initial equals, and not only do the G's cancel, I get 0.5R plus 2R. Those are like terms. What is 0.5R plus 2R? No. We're not done yet. Just generically, algebraically, what is 0.5? And here's why I told you that I like this question. I didn't say I like this question, I like this. I just love this clean answer. You want to know the minimum height? It's 2.5 times the radius. Look at all the work that we did. We did circular motion, we did conservation of energy, and you end up with such a beautiful little expression. I'm willing to bet if you're a ride engineer, in the same way that all of you have memorized 9.8 and MA, I'm guessing that's something a ride engineer would just have at their fingertips. Now, of course, Sam, in real life, you would build the hill much higher than that, but you're sure not going to build it any lower than that because it's not going to work very well. Now, there's our generic version. Let's actually solve this question. Somebody said, 10. Are you saying you can actually do this? Sorry, it was 4, right? You can actually do this in your head. Yeah, the hill has to be 10 meters high. And that'll give you a normal force at the top of 0. You would feel weightless. You would feel like you were falling out of your seat. By the way, I should have put a part A there. Lorenzo, what's part B you want me to find? Where? Where? To the where? That makes a complete, you have to tell me where. Otherwise, I don't know what my free body diagram looks like. Wow, you overcomplicated that. Did I say free body diagram? Let's do a free body diagram at the bottom. What are the forces acting at the bottom, Lorenzo? Get the obvious one. What else? Which way? Bigger, smaller than mg? In fact, I'm going to get this. If I go to part B, I'm going to get normal force minus mg equals mv squared over r. Yes? I'm going to get normal force equals mg plus mv squared over r. I'd like to see if I can figure out what v squared is. Now, what is v squared going to be? If we start here, it's how fast we're going here. So I'm going to do, because there's a change in height and a change in speed and a curvy path, I'm going to do conservation of energy again, but in my second time, final is going to be down there. You okay with that? I think if I look at this, I think PE final is also going to be 0 then. In fact, and I'm doing this because I didn't give you enough room. I've realized I'm running out of room to write, and I know how much more I need to write. I think we can say mgh initial equals a half mv final squared, where v final is how fast we're going at the bottom. And that would be how fast we're going at the bottom right when we hit the loop and right when we exit the loop. Nick, can grown-ups and little kids go on this? Okay. I was going to get the v by itself, but wait a minute, there's a v squared over here. I'm going to get the v squared by itself. How? It looks like vf squared is 2g, pause. What would be a more clever way to write h initial? 2.5 what? 2.5 what? I went to go see a pirate movie the other day, but I couldn't get in because it was rated R. Nothing. Okay. Yeah, we've come a long way from attention deficit disorder. Sadly, that's as good as it ever is going to get. What's 2 times 2.5 in your head? So VF squared is 5 GR. Go walking back over here. We get this. The normal force at the bottom is mg plus m over r, 5 GR. Oh! Now the m's don't cancel, but I notice something that cancels. The r's cancel. Well, that's kind of nice. And you end up with mg plus 5 mg. What is mg plus 5 mg? The normal force at the bottom, if it's a circular loop, you're pulling 6 G's, and they don't let you do that at an amusement park ride. That's not safe. Now, the first roller coaster with a loop that was built. I forget the name of it. I believe it was built in the 1920s at Coney Island. And all it was, you climbed a big stairway to get very high, and you got on the top of the hill yourself into a car, and they did actually have a circular loop because they didn't know any better. And I've read they permanently had ambulances and nurses stationed at the bottom of the roller coaster. You would just go straight down through one loop when you're at the bottom and then come to a stop. And people would get off with whiplash and nosebleeds. I mean, they loved it. People just loved it. They would, I'll go on it again. Okay. What do most roller coaster loops look like? If you look at them, this is not on your test. This is nerd trivia because, roller coasters. If you look at them from the side, most roller coaster loops look like that. We call that a clothoid loop. They're teardrop shaped. The closer it is to a circle, the more you'll feel the G's. So I believe the first steel roller coaster to have loops or multiple loops was at Six Flags Magic Mountain. I've forgotten the name of it. It's a white coaster. I've been on it, and if you look at the loops from the side, they do look like that. How many have been on California Screaming at Disneyland? That loop, if you look at it from the side, it looks very circular. Now, partly they've done it with an optical illusion. They've put a sun behind it, a picture of a sun, but that sun is not circular. But because it's a sun, your brain thinks it's circular and just overrides what your eyes are seeing. They've done a lovely optical illusion. But it's the most circular loop that I've been on, because if you go through there, you do feel a fair bit of G's, okay? Where a lot of the other ones, you can only tell that you're going in a loop because of what your eyes see you, not because of what your body tells you. So none of you have been on a circular loop, because if you did that, you'd be pulling about 6 G's. Instead, we build a clothoid loop, a loop of continuously decreasing radius, if you want the calculus equation definition of it. Nerd trivia. Put your pencils down. You have a take-home quiz to work on. Most of you have not finished lesson 4. I gave you a lot of questions on that one, so you can work on that. I'm going to finish this lesson and assign a bunch of questions, but if you want to get a head start right now, in theory, you could do number 1, number 2, number 3, number 4, and number 5, but I'm going to be assigning those next class. Okay? Work on the take-home quiz first.